Welcome to Maths Practice. In the previous videos, we have discussed the first chapter real numbers and the second chapter polynomials. Here we are going to discuss linear equation in two variables, which is the third chapter. In this video, we will see all the key concepts and the methods to solve linear equations in two variables with the help of examples. Also, in the next video, some very important examples will be discussed, whose link I will be giving in the description box. An equation written in the form ax plus by plus c is equal to 0, where a and b are not equal to 0 and a, b, c are real numbers, is known as a linear equation in two variables x and y. It is linear because the power of x and y is 1. A pair of linear equations aix plus biy plus ci is equal to 0, I is equal to 1, 2 means a pair of two linear equations a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. It is very useful in day-to-day situations. For example, the length of a rectangle is 4 less than the thrice of its breadth. The perimeter is 110. How we will express it in the form of linear equations in two variables. Suppose if x and y are the length and breadth of the rectangle, then the pair of linear equations will be, first of all, length x is equal to 4 less than thrice of breadth, means 3y minus 4, or x minus 3y plus 4 is equal to 0 will be the first equation, and perimeter is twice the length plus breadth, means 2x plus 2y is equal to 110, or in simplified form x plus y minus 55 is equal to 0. We have just seen how to algebraically represent a pair of linear equations. Now let us see the graphical representation of a pair of linear equations. There are three cases. Let us take the first case, when the two lines will intersect at a point. Since both are linear equations, both will represent a line. The first case is the two lines will intersect at a point. For example, the teacher buys 3 erasers and 5 pencils for rupees 13. Later she buys another eraser and 2 more pencils for rupees 5. First of all, let us express it. Let x and y be the price for 1 eraser and 1 pencil respectively. 3 erasers and 5 pencils means 3x plus 5y is equal to 13, and 1 eraser plus 2 more pencils means x plus 2y is equal to 5. So we have two linear equations. First, let us get the table of points. We know that 2 points are sufficient to represent a line. You can plot more than 2 points also. 3x plus 5y is equal to 13. Means we can write y is equal to 13 minus 3x by 5. You can get some points by trial and error. In the first case, suppose if we take x is equal to 1, y will be 13 minus 3 by 5 or 2. Similarly, we have taken x is equal to 6, which will give y as minus 1. Let us get the table of points for x plus 2y is equal to 5, means y is equal to 5 minus x by 2. If we put the value of x as 5, we get y as 0. If we put the value of x as 1, we get 4 by 2, which is 2. Now we will just see in the graph that both the lines will intersect at a point which is 1, 2. And this point will give us a solution of the given situation. So both lines intersect at the point 1, 2 means the price of the eraser is rupees 1 and that of a pencil is rupees 2. Let us see the graph. When we plot the two lines on the graph using the points just obtained, we get that both the lines are intersecting at the point 1, 2. That means in this case, there are two lines which are intersecting at a single point or a unique point, which gives the solution of the pair of linear equations. In the second case, the two lines will not intersect, means they are parallel. In this case, the solution set is the null set or empty. In other words, we can say that the system is not consistent. We will see the condition for consistency later on. For example, let the equation of two lines be 3x plus 4y is equal to 10 and 3x plus 4y is equal to 15. Now when we plot these points, we will be just seeing that the lines are parallel. Since the lines are parallel, there is no point at which they will intersect, means there is no point which is a common point for both the lines. So there is no solution to this pair of linear equations. You can see in the graph that both the lines are parallel, so there is no solution to this pair of equations. In the third case, both lines are identical or they coincide, means they are the same line. That is, it can have infinitely many common points or solution. All the points on the line will satisfy both the equations, so they can be said as the solution. For example, the cost of one pen and one pencil is rupees 7, while the cost of 3 pens and 3 pencils is rupees 21. So x plus y is equal to 7 and 3x plus 3y is equal to 21. We can very well see that both the lines have the same points. We can see in the graph that the single line corresponds to both the equations. So all the points on this line can be said as the solution. Let us see the graphical and algebraic interpretation of any pair of linear equations. This is very important. In the first case, example is given x minus 2y is equal to 0 and 3x plus 4y minus 20 is equal to 0. Now in each of the cases we will compare a1 upon a2, b1 upon b2 and c1 upon c2. So a1 upon a2 is 1 upon 3, b1 upon b2 is minus 2 upon 4 or minus half, and c1 upon c2 is 0 upon minus 20. In this case, a1 upon a2 is not equal to b1 upon b2. So both lines would be different and they would be intersecting at one point. So there will be exactly one unique solution. So for a unique solution, the condition is a1 upon a2 should not be equal to b1 upon b2. And the lines are said to be consistent. The system is said to be consistent. In the second case, we are given another pair of linear equations. In this case, a1 upon a2 is 2 upon 4 or half, b1 upon b2 is 3 upon 6 or half, and c1 upon c2 is also half. So a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. So the lines are coincident lines, means only one line would be representing both the equation, and any point on this line can be a solution. So there will be infinitely many solutions. This system can also be said to be consistent. In the third case, you have another set of linear equations. Here a1 upon a2 is half, b1 upon b2 is also half, but c1 upon c2 is 1 upon 3. Means a1 upon a2 is equal to b1 upon b2, but they are not equal to c1 upon c2. So in this case, the lines are parallel, and in this case there will be no solution, or this system of linear equation is said to be inconsistent. We have seen graphically how to solve a pair of linear equations. Now we will see algebraically or mathematically how to solve them. There are three main methods. We will discuss each method in detail with the help of an example. The first method is called the substitution method. Now let us take an example and see step by step how to solve it. Solve the following system of linear equations. 2x plus 3y is equal to 10 and 3x minus y is equal to 4. Now the first step is find the value of y in terms of x from any one of the equations. So we make y as the subject of formula. So 2x plus 3y is equal to 10 will give y is equal to 10 minus 2x upon 3. Second step is we substitute the value of this y in the other equation. The other equation is 3x minus y is equal to 4. So in this put the value of y we have just got, which is 10 minus 2x by 3. So now we just reduce this equation, we solve it. What do we get? 11x is equal to 22 or x is equal to 2. What we have done is just substituted the value of y in the other equation. Now since we have obtained x, we just have to substitute the value of this x and obtain the value of y in any one of the original equation. We can substitute the value. So we substitute x is equal to 2 in 2x plus 3y is equal to 10, and hence we get y is equal to 2. So here 2 and 2 means x is equal to 2, y is equal to 2. This is the solution of the above pair of linear equations. Since we substitute the value, it is called the substitution method. The second method is called the elimination method. Let us take an example. The ratio of present ages of mother and daughter is 8:3. After 5 years, the ratio of their ages will be 9:4. Find their present ages. Now first of all, let the present age of mother be x and that of daughter be y. So according to the example, the ratio of present ages x upon y is equal to 8 upon 3. So this gives us 3x is equal to 8y, or 3x minus 8y is equal to 0. The second says that after 5 years, the age of mother will be x plus 5 and the age of daughter will be y plus 5. So x plus 5 upon y plus 5 is equal to 9 upon 4. Now solving this, we get 4x minus 9y is equal to 25. So now we have obtained two linear equations. First step in elimination method is multiply both the equation by a non-zero constant to make the coefficients of any one variable equal. Means the coefficient of x in first equation is 3 and that in second equation is 4. Now if I want to make both of this equal, I can multiply the first equation by 4 and the second equation by 3. Remember, you can also do this with y. But over here we multiply the first equation with 4 and the second equation with 3. So what we will be getting is 12x minus 32y is equal to 0 and 12x minus 27y is equal to 75. So we have obtained the coefficient of x in both the equation as same. In the second step, we eliminate the variable whose coefficients are equal by either addition or subtraction of equations. Hence we get a linear equation in one variable. Means now we are having these two equations 12x and 12x, so we subtract equation 2 from equation 1. Then what do we get? We are simply reversing the sign. So we get minus 32y minus plus 27y, which gives minus 5y is equal to 0 minus 75, which is minus 75. Now in the step 3 we just solve this equation. So what we get is y is equal to 15. So we have made the coefficients equal for one of the variable and then we are subtracting the equations. Hence we get the value of one of the variable, which is y is equal to 15. Now simply in the fourth step we substitute this value in any one of the original equation and get the value of the remaining variable. Substituting y is equal to 15 in 3x minus 8y is equal to 0, we get x is equal to 40. So the solution is the present age of mother is 40 years and that of daughter is 15 years. But remember, this is a good method and it is used most of the times. The third method is the method of cross multiplication. Let us take an example. The sum of two numbers is 70 and the difference is 6. Find these numbers. Let x and y be the two numbers. So now what we have is x plus y is 70 and x minus y is 6. We will solve by method of cross multiplication. First step is you just note the coefficient. You compare it with the equation a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. So we get a1 as 1, b1 as 1 and c1 as minus 70. Similarly from second equation a2 1, b2 minus 1 and c2 minus 6. In the second step, the denominator is obtained by the cross multiplication of the coefficient. Just let us see this step. Now in this step, take care while writing the coefficients. X upon, now remember over here, the simple trick is when you are writing x upon the coefficients, just ignore all the coefficient of x and for the remaining coefficient write in that order. Means x upon b1 which is 1 and c1 minus 70 and b2 minus 1, c2 minus 6. So for x we ignore the coefficient a1 and a2. Similarly for y we ignore b1 and b2 and write the remaining in order. Means first we will write c1 c2 and then a1 a2. So y upon minus 70 which is c1, a1 is 1, c2 minus 6 and a2 is 1. Now the constant. So it will be always 1 upon the remaining terms. So that is equal to 1 upon, we just ignore c1 c2 and we write the remaining in that order. So it is 1 upon a1 1, b1 1, a2 1, b2 minus 1. Now in the denominator we just cross multiply, or in other words we just solve this matrix. So x upon minus 6 into 1 minus 1 into minus 70. That means minus 6 minus plus 70. Y upon minus 70 minus 6 and 1 upon minus 1 minus 1. So actually we are solving the determinant over there. So solving this, we then get x is equal to 38 because x upon minus 76 is equal to the right hand side 1 upon minus half. So we get x is equal to 38. Similarly, y upon minus 64 is equal to also 1 upon minus 2. So we get y is equal to 32. Hence the two numbers are 38 and 32. So in this method, just remember that if you are writing for x, just ignore the coefficient for x. If you are writing for y, ignore for y and write in the order, and similarly for the constant term. Remember, if the method is not given, you can use any of the three methods to solve the pair of linear equations. Now the next is a special case, equations which are reducible to a pair of linear equation in two variables. For example, solve the pair of following equations: 5 upon x plus 3 upon y is equal to 8, 3 upon x plus 5 upon y is equal to 24, x and y not equal to 0. Now over here, 1 upon x is given, so we will take 1 upon x as some another variable, say a, and 1 upon y as some another variable b. So now we get a simplified form of equation, which is 5a plus 3b is equal to 8 and 3a plus 5b is equal to 24. Again, any method can be applied. We will use the elimination method. So very simply, what we will do is we will multiply the first equation by 3 and second by 5, because the coefficient of a in first equation is 5 and that in the second is 3. So we want to make both of them equal. So we multiply first equation by 3 and second equation by 5. So now we get 15a plus 9b is equal to 24, 15a plus 25b is equal to 120. Subtract the second equation from the first, means just reverse the sign. So we get b is equal to 6. Now substitute b is equal to 6 in our equation 5a plus 3b is equal to 8. So what we get is a is equal to minus 2. Now again, what is a? A is 1 upon x. So a is minus 2, which gives x is equal to minus half. Similarly, b is 6, which gives y is equal to 1 upon 6. Hence the solution to this pair of equation is xy, which is minus half and 1 upon 6. In this video, we discussed all the important methods to solve a pair of linear equations. Hope it was useful. In the next video, we will be discussing all the important examples. So please do like and share this video and subscribe to my channel Maths Practice by pressing the bell icon. Thank you.